Yeah, hello everyone. We'll see how indexing and hashing will be happen. Previous to this, we were discussed about file organization and sequential file organization. So now we will try to see what is the advantage with indexing and hashing in your upcoming video. So first we'll try to start with the indexes and then we'll go for hashing. So what do you mean by index and what is the need of your index? So it was very simple. Actually, we were creating some kind of tables. The table is consisting a lot of information, which is consisting from 1 to 1 lakh records in your table. Just assume that. So for example, if you want to retrieve any information from this table, so you need to compare the search key from the starting index positions to whatever the value it is going to be represented. So if you want to find the 1 lakh records, so you need to do the 1 lakh comparisons to find the element. So instead of doing these many number of comparison for only a retrieval or for only an insertion, so we need to make this process bit faster. To make this happen on your table, I'm going to create some kind of index. So this is also a database object which consists very limited information. By using this information, we can trace the value where exactly it is going to be sit in your database object. So how this is going to be happen is the table is going to maintain a key and a pointer. This pointer is pointing to the exact position of your database object. Maybe it is going to point to every record which exists in your database object, or it is going to point to some kind of save points. For example, first record is one pointer, and second we have pointed to 50,000, and next one we were pointing to 1000. So like 3 different kind of pointers we were created to your database. So now whenever the user wants to access information, they first approach index. By using this index, directly they can meet to the particular point where this pointer is triggering. From that, your searching is going to be happen, or to insert or update or delete. So by using this, we can minimize the number of comparison which is existing on your database object. So the index is nothing but index is an object which consists the pointers to your database object to make the retrieval effective and efficient. So this is one kind of approach to retrieval. Things has to be happen faster. So in this index, we have different kind of indexes, like your bitmap indexes, ordered index, primary index, secondary index. There are several kind of types we have, and after that normal index will created on based upon primary key. So it is not an efficient approach. So I want to make it this hierarchy into minimal level. So to happen this, we need to go through with an algorithm called B plus tree to how this accessing is going to be a bit faster in the index. So we'll try to see them one after the other, and we'll go for B plus tree representation. Now see this as per the discussions of previous slide. So there is indexing is a data structure technique to improve the efficiency to retrieve the record from the database object. So as per my representation, index is a database object which can be created on top of your database object to improve the efficiency in the retrieval or accessing of your records from the database object. So what your main agenda of your index is, it should be speed up your data accessing from the database object. So how this will be created? So indexes doesn't consist the many attributes. It may consist only 2 representation. One is the search key. It means the particular value, and this value is pointed to a particular position in your database object. So these are the 2 values which are going to be identify the records in the very unique manner. So your index file is consisting a combination of search key and pointer, so which are pointing to the records which exist in your database object. So in this indexes, it is not useful for the small database object. If your file is larger, then it should be well suited for your to create index based indexes for your database object. So there are several kind of database objects we have. As per this, ordered and hashes are there. Hashes is one kind of technique, and index is another kind of technique. So we'll try to see in your indexes. It is basically works based upon the search keys are stored in your a particular given order. So how many types of indexes we have? So we'll try to see them in your next representation. So these are the basic advantages we have. Accessing type will be efficient, time should be minimal, insertion, deletion will be speed up, space overheads will be there, because where to store if already a value is existing, so index would not be able to give an answer. So for the fast retrieval only your index is going to be helpful. And next we'll try to see them types of your indexes. So there is two types of indexes we have. One is a single level index and there is multi-level index. So multi-level indexing, it should be for every search key. If you are consisting only one value, if it is pointing to the one value, then it will be covered as single level hashing. Multi-level means in a single node there are multiple values can be represented, x, y, z. One is pointing to some of the records and another one is pointing to the sum of the records and another one is pointing to some of the records. So it means what? A single value can map to the multiple variables, then it will be called as multi-level indexing, or level based representation will be happen on your database object. Multi-level indexing, exactly it is pointing to the single value of your particular record, so then it will be single indexing. Inside a single index we have primary index, clustered index and secondary index. So see, this primary index means if you are going to create an index on a primary key based, then it will be called as primary index. It's very simple. While creating your primary key on your database object, if you are going to create an index on the particular object by using that primary key, then it will be called as primary index. So by using your primary key representations, your index will be handled. And secondary index means, so we need to maintain one more representation for your indexing level. So there is one more dependency we have. So for example, I don't want to include everything into a single table, so I want to split this. So primary index will be pointing to the next level indexes. These indexes are going to map to record. So this is how your secondary index is going to be happen. And clustering index means group of elements are going to be mapped to a single index value. So then it will be called as clustering index, right? So in your multi-level there is a static and dynamic approach we have. We'll see them one after the other. Order index will consist as per this notation. So one after the other your keys are going to be stored. It is similar to your primary indexing, which is based upon primary key representation. Secondary key means we have different kind of sequential order for your file. So it is called as secondary indexing. So this is how it is going to be work. In your primary index we have two different kind of approaches. One is dense, second one is sparse. So while creating your table, every entry which exists in your index is mapped to the database object record. So every pointer is mapped to the individual record. So then it will be called as dense index. So every search key is mapped to the value. For example, it is not guaranteed that every element has to be consist or mapped to a particular record. So it is not work like this. For example, I am pointing from here to this element. From here I am pointing to this element. From here I am pointing to this element. So here our target is only this particular index will map or it will identify the record which exists in your table. That's it. So every entry which exists in your index is mapped to the one record in your database table. So then it will be called as dense index. See this example. There is a huge data in your database object. So it may consist many records. So from this we have very limited representations in left side your indexes. So this index is every entry is mapped to the one record. So which may helpful for while retrieving your data. Maybe by comparing biology pointer is pointing to this or computer science is pointing to this. So depends on this we are going to retrieve your information. See, I am not mapping to every element. Computer science is existing one and there are many kind of computer science related records in your table. So this is how your dense index is going to be work. Space index is one kind of index. So it doesn't point to every element, right? So a key will be pointed to the particular value and based upon this value, so we are going to identify the elements. See, this 10101 is one kind of attribute, and from this 343 is one attribute. So in between, all the values will be based upon one condition is going to be returned. For example, if you are giving 32,341, so it should not be identified by using this key, it should be identified by 1010 attribute. So after 32,345, if you are getting any value, so it will be identified whether it is identifiable by using this pointer or it is will be identified by next value. So depends on this, your data will be identified in your particular given. So we could not able to maintain every record should be mapped to the every element which exists in your table. So that's the beauty of your space index file. So right, so then next so we have this kind of representation. So there is a index will be exist, and this index may be pointing to several different kind of data blocks. So this block may consist many number of address locations. So now it is going to be a good approach to make betterment in your retrievals and other things, and it is also occupies very less space and less maintenance is will be represented when compared with the dense indexes. So next we have secondary index. So this is very simple. It is, so this is one kind of index, primary index. So this will be pointing to the next level index. So this next level index will be mapped to that particular record. So there is one more index will be exist between your data and primary index. So then it will be called as secondary indexes. So most probably these things are going to be done. And next, clustering index. So this looks like this. So it is based upon your data storage and where exactly it is going to be stored. So this pointer is pointing to some kind of memory representation, and which are going to be either based upon the group or based upon the physical structure of your file. So all the related data is going to be stored at a single point, so that this address location will be represented in your indexes. So all together will be retrieved by using a single index pointer. So then this group will be treated as clustered index. See, clustered index is basically works on physical structure. Next, cluster index is more efficient, faster, and to retrieve your data, because it should be storing your data in the bulk representation. So next, non-cluster index means it focus on logical structure, how the data is mapping. So there is no grouping will be there, and randomly you can write your data at any point of any file which exists in your database. So this is how your clustered and non-clustered databases are going to be works. So multi-level indexes, so it's simple. There are several levels we have to reach your physical files. So outer index will be pointing to the inner index pointer, and inner pointer will point to the address bucket, and address bucket will point to the particular record. So these many level of indexes we have to retrieve your data. So this only useful whenever you are having a large database. So it will not be suited for small databases, because your data set is very minimal, and if you are going to implement multi-level representations, there is no meaning for your data representation, right? So there is one consideration we have to do. If a deletion will be happening, what is going to be happening? If a record insertion will be happening, what is going to be happening? So dynamically the data is going to be changes, right? So this is how your index will be handled. So an observation we have to do, and if the data is going to be deleted or newly inserted data will be there. So in your two different kind of representation we have to create indexes, and either it should be based upon the search key value. If the value doesn't appear, so you should insert the data in your dense indexes. Why? Because exactly it is mapping to the record from your index to database object. And in the space indexes, no need to change your cluster and try to create a new block to store your information, because here we are storing the data based upon the blocks. So first primary value will be mapped, and secondarily we don't want to worry about it. If the value is existing between the limitations, then you can insert your data. So this is how your things will be added in your indexes. right? Primary index and static index and dynamic index. It seems to be very simple, and there is nothing about it. In your static indexing is basically it's already predefined representation. It doesn't allow to expand its representation. For example, space, memory, right? So once it is created, it should be fixed length of representation. Dynamically, it is not going to be change its properties of your indexes. So if you want to change that, there is a time consuming process will be there for every representation. Instead of this, if we are going with the dynamic indexing, so it is more flexible compared with your static indexing, but there is a kind of overheads will be exist in your database. Why? Because it is dynamically updating its details. So in that process, maybe some kind of overheads will be appearing while generating in the index table. So to overcome this kind of representation, we need to go for hashing related content. So we'll see them one after the other, and it matters on based upon size of this database and frequency of database you are using, and depends on your application which are going to be creating. So most probably we are going to use a very basic representation static indexes. So if the database is large and dynamically it is changing, so if a transactional database keep on doing insertions into your table, so then you need to go for dynamic indexing. So next, instead of doing all these things in a single level representations, then we need to make them multi-level notation. So if you want to do that, you need to go for B+tree indexing. So there is a multi-value representation is there. Each value will be pointing to the multiple values related content. So then this is how hierarchy will be generated in your table. So which makes your retrieval should be very easy. We'll see them in your next coming video.